Let's talk about hypotheses. Hypotheses are something you talked about as early as the third grade. Maybe you learned about them, you remember the phrase that they were called an educated guess. Well, that's about right for third grade, but now we're in college and we're talking like scientists. So let's scroll down to the section on hypotheses, section 6, there it is right there. A scientific hypothesis is usually a direct statement, not an educated guess. Something like chronic use of ecstasy, or MDMA, causes brain damage. Notice it's a bold, direct statement. There's no question mark at the end. Okay? The reason for that is because science sets out to test this false. That's how statistics are used. Turns out it's much easier to prove something false than something is true. And that's why we have something called the null hypothesis. I'll explain that in a minute. In any experiment, we have two groups, a control group and an experimental group. So the experimental group gets the manipulation. In this case, it'd be given ecstasy. The control group would not. And then at the end of the exposure to the manipulation, we'd measure the effect. The effect here is some sort of brain damage. Okay? So there's always at least two groups. Research hypothesis is a direct, bold statement suggesting that there will be a difference between the two groups. The experimental group will see a difference in this case, brain damage. The null hypothesis suggests that there will be no difference between the groups. We do this in order to prove this true. If we can reject the null hypothesis in a sort of a double negative, say that we reject the null hypothesis, we say that there is in fact a difference between the groups, then we can say that our research hypothesis is true. So research hypothesis is a bold, direct statement of fact. The null hypothesis suggests that there is no difference between the groups.